Part B. It says, given that the probability of A union B is 4 on 9, the probability of B given that A is 1 on 3, and the probability of B given that not A is 1 on 6, Part 1 says, show that the probability of A is 1/3. Okay, so we can use what we know from Part A. Probability of A or B, union B, is equal to the probability of A plus the probability of not A intersection B. And we can also use the conditional probability formula. This is actually the probability of A plus. Here we can split this up. If you have your formula book in front of you, this is actually the same as the probability of B given that not A times by the probability of not A. These are the same. If you're more familiar with, this would equal that over that, but if we just rearrange it, that's what we get. So the probability of A or B, we do know it was given as 4 on 9. Probability of A, I'm just going to make that for now. I can just leave it as the probability of A. Probability of B given that not A is 1 on 6. And the probability of not A is just 1 minus the probability of A. Okay, so if I rearrange this, I'll be able to solve for PA. Now, we currently have some fractions, so I want to multiply everything so there's no denominators. This is 9, this is 6, so if I multiply everything by 18, I'm going to get 8, because the 18 and 9 will cancel out to be 2 times 4. This will be 18 probability of A plus 18 times 1/6 is 3 times 1 minus the probability of A. And then from there, I can expand and group my terms. So this will be 18 PA and minus 3, so it'll be 15. And 3 on the other side will be 5. So therefore, 5 on 15 is the probability of A, which is 1/3. Okay. Now for part 2. Let me get my black pen. So for part 2, it says, hence find the probability of B. So hence find probability of B. Okay, so the probability of B, look what I did up here. The probability of B, I made that equal to these two terms here. And we showed that on the Venn diagram. This is actually the probability of A and B plus the probability of not A and B, because this will find the intersection bit, which would be in B, and this would be the only B bit. Now I can expand this out using my conditional probability formulas. The probability of A and B, again, similar to what I did in this section here, this is the probability of B given that A times the probability actually of A. Conditional probability, that's this. And then this here, same as this bit here, this is the probability of B given that not A times by the probability of not A. Now the probability of B given A, that is given in the question, that's 1/3. So it's 1/3 times the probability of A, we just worked out, it's 1/3, plus the probability of B given not A, that was given, that's 1/6, times the probability of not A. Not A will be the opposite of 1/3, so 2/3. This will be 1 on 9 plus 2 on 18. and this can be written as 1 on 9 plus 1 on 9, which is just 2 on 9. Okay, bit of a long question, but we found the answer.